In this video, I'm going to show you how you can identify markers associated with your object. So let's say that you now have a segmentation, so we're going to load it. So either fully manually annotated or the result of a segmentation, like a deep learning based segmentation, or the result of segmentation that you had corrected. And you also have segmentation of your regions, again, either manually or with a segmentation approach, like it could be a semantic segmentation for the regions, it could be an instant segmentation with the objects. And now you want to identify the markers that are associated with your nuclei, so in that case PH3 and A2F3A. So to do that, you can use the marker annotation mode. So as you can see, this is the same, and here you can either load a previous annotation of your markers, or you can add a new marker. Let's do that. So when you hit add new marker, you see you can define, you can choose between nuclear marker, nuclear membrane marker, and cytoplasmic marker. So here we only have nuclear markers, but if you want to use the nuclear membrane marker and cytoplasmic marker, which in that case actually is just looking in regions that are outside of your nuclei for cytoplasmic, or at the membrane a little bit outside of the nuclei for nuclear membrane marker, you need a plugin. I'm going to show you how to use, how to add it. If you go to help, update, so as we did before to install Annotater, you're going to see in the manage update sites you have the 3D image J suite, this one. So I'm not going to install it because again we only have nuclear markers, but if you were to use nuclear membrane or cytoplasmic marker, you need to add this plugin to be able to run Annotater smoothly, just to run it. So let's do it again. So we're going to start with PH3. So I want to add a new marker, which is a nuclear marker, which corresponds to channel 1, and I'm going to define it manually. Okay. So when you do that, you see you have actually 4 different patterns. So it's just a functionality to have 4 different patterns of markers, which is the case with PH3, even though we don't have 4 different patterns, but we have 2 different patterns. We have diffuse PH3 like this, okay, and we have punctate PH3. Okay, so the diffuse PH3 corresponds to mitosis, and the punctate correspond to G2, about the half of end of G2, maybe a little bit more. But so you first have PH3 is first punctate and then become diffuse. So let's say I want to define diffuse as P1, so I can just, then you see you just hit the nuclei that have this particular phenotype. It's fine. And P2 is going to be this guys, okay? So you see it's pretty fast to do, and here I'm not going to be very yeah, this one's probably more. You see here it's in between. I would define it as punctate. So it's not always easy. Sometimes you know it's in between, so you need to make a decision. And here I'm going really fast, so maybe I'm making a few mistakes. I guess it's not too bad. So I missed this one, I missed this one. So you see here, so that's a way to manually define your markers. Now let's add another marker for A2F3A. So let's define it with a thresholding tool. So it's a nuclear marker. We're going to use thresholding, and we are doing it for channel 2. So when you do that, you have this this new tool for thresholding that appears, and it's actually using the thresholding tool from ImageJ, And you have two sliding bars, one which define a threshold on the intensity and one of the region. So basically here it means that if you have 35% of the pixels in the nucleus that have an intensity above 127, then it's a positive nucleus. So I'm not going to change this because I think it's a good threshold for this, and then I can just play with that. So now you see when you have positive nuclei, they are surrounded in magenta here. So if I go very far, of course I have everything that is positive. So it might be a good idea to have a look at it before. Here I don't know if I'm pushing it too far. I think here we're about right. If I look, so maybe it was too much. At the same time, I think no, I think it was not enough. So you can correct it then and add some you think that should be there too. Yeah, here it's tricky maybe. It's not that easy in that particular case. Maybe this one. Of course, you can do the reverse if you think that you got one that shouldn't be there. Like I don't know, this one. It's not positive. You can remove. You can put it back. All right, and you can also use. So I'm going to show you. You can use a regression to do it. So traditional machine learning, it's a logistic regression. So I'm going to do it again for I2F3A. So it's nucleus marker, and I'm going to use machine learning. So this is based, and it's channel 2. This is based on the average intensity, standard deviation of the intensity, the size, and the ellipticity of the cells. So I'm going to look at them. And here, so you need to define, you have two different possibilities, positive cells and negative cells. So you need to define several positive cells, representative of what you see. And you need to define negative cells. So let's say this. And then you can train it. And if you're not happy, you can annotate new nuclei. So let's say I think that this should be positive. I'm going to add it. And I can train it again. And do I see some that I wouldn't like to have? I think it's not that bad here. But you can go that way. You can also change if you want to do it on other images. You know, if you have a whole batch of images, it might be really a good idea to use this logistic regression over several images, just to make sure that you're robust across images. So you can do it. So let's do it here, for example, load. So you need to define a couple of input image and segmented. So I'm going to choose out of a couple of images. Let's open this one. And the corresponding segmentation. All right. And so this was manually, so it's not working because it's not a way to define it. And if I use the training again here, you see, so I forgot to select marker 3. That's what it didn't work. So that's the previous training. So here you can add new nuclei in your training dataset. Like here, it's too sensitive, I think. So I'm going to remove this one, for example, and this one, and I can train it again. And you can go on, and so when you're happy, you can then batch process a whole set of images. You see, you also, the thresholding was conserved, so that's the results with the same thresholding and same parameters that were used for the previous image. So you can also look at your thresholding, see if it makes sense.